let's talk about sets. Sets are numbers that can't be simplified into a whole number or a fraction, but they help us deal with irrational numbers. Sets, like the name sounds, they are kind of absurd type of numbers. If they are absurd or irrational, then why should we study them? Okay, let's see. It is important we understand sets because even though they are weird kind of numbers, they allows for precision. Sets help us to express numbers more accurately than decimal approximations. Root 2 is a typical set, which subsequently you understand. It's a typical set, and if it's written in full, this is all of it. You have to write all of this 1.4142, a whole lot. And ordinarily, no one is going to write all of these numbers in full. At best, it will be a 3 decimal place approximation or 4 decimal place approximation. And in areas where precision is important, it will be inaccurate to express numbers that are shortened or approximated to a few decimal places, and so using the said value for it becomes important. Again, in further topics like trigonometry and then calculus, sets are used in these topics, and so if you understand them at this point, then it will help you in understanding such topics as well. When dealing with sets, you are going to come across these two kind of numbers, rational and then irrational numbers. What are they? Rational numbers are numbers that can be expressed in the form of a ratio or fractions, and so rational came from the ratio word, right? So 2/5, 3/10, -11/32 are all rational numbers because you can easily express them in a fraction or as a ratio. Their fractions or decimal form terminate or they repeat in a particular pattern. However, irrational numbers, when written in a decimal form, are infinite and do not occur in a particular pattern. They do not repeat a particular pattern. And it is these irrational numbers we are calling sets. Okay, so examples of them include 2√3, √5, and then pi. Alright, but it is important to note that a rational number multiplying an irrational number makes an irrational number. So 5 as a rational number multiplying by 2 as an irrational number gives an irrational number 5√2. Again, square roots of perfect squares such as 4, 9, 16 are not sets. That's what we mean. If you see a perfect square under a square root, it doesn't mean it is a set. This because square roots of numbers are the numbers to the power half. So for example, if you take x, square root of x, it can be expressed as x to the power half. Then again, for these perfect square numbers, they can be expressed as x to the power 2. And so the 2 and the half multiplies and cancels out, giving it just x. Okay, that's what we mean if we are to show by an example. Square root of 4, for instance, is 4 to the power half, like we've already said. Then 4 itself can be expressed as 2 to the power 2. So 2 to the power 2 or 2 times 2 is 4. Right? So all of this expression now becomes this. Square roots becoming to the power half, and then 4 expressed as 2 to the power 2. So we see that this 2 cancels this 2. So we have just 2 alone, or 2 to the power 1, which we express as 2. The same thing happens here. Square root of 25 can be expressed as 25 to the power half. Now 25 itself can be expressed as 5 to the power 2. So this and that cancels, giving us just 5. This gives rise to an important aspect of sets we should know, simplifying sets. Because if a number is under a square root, or the fact that a number is under a square root doesn't necessarily mean it's a set. Means at times it becomes important we simplify sets, and that is what the next topic will talk about. So make sure you check it out.